Canadian anti-stealth tracking technology kept secret for over 40 years. In 1990, a team in Vancouver, Canada, was able to passively track in real time the re-entry and landing of the Space Shuttle Discovery from a distance over 5,000 kilometers away until it landed and rolled to a stop 1,600 kilometers away from the Detector. This tracking technology was not new, just the item being tracked was, and it provided insight into the ultra-long range of the Detector and immediate speed of the signal they were tracking. The detection instrument was less than 1 meter in length and height. Donald Hings, a Canadian scientist, is recognized as the inventor of the walkie-talkie in 1937, just prior to World War II. He had over 50 patents, but what he felt was his pinnacle achievement has been kept secret from the 1980s, as it can instantly track all manner of aircraft, including stealth and hypersonics, up to and well over the horizon. Hings was considered a leading expert in radar. He invented the technology used for the DEW line, Distant Early Warning Line, operated by the North American Aerospace Defense Command, or NORAD for short, for over 30 years. Guy Kramer, the president and CEO of Hyperstealth, is Hings' grandson and was Hings' research assistant from 1986 to 1991. Guy has since followed in his grandfather's footsteps with 16 issued patents containing 571 claims, with 21 more patents approved, but not yet issued, with a further 82 claims. Kramer realized in 1985, prior to assisting his grandfather, that Hings' method would also work on detection and tracking of every stealth aircraft, and convinced Hings not to publish, as it could ruin the multi-billion-dollar American stealth programs that were active or in development. Hings concurred. Hings received the Order of Canada in 2001, the highest honor for a civilian Canadian, and passed away in 2004 at age 96. He had 56 patents to his name. Kramer has been keeping Hings' biggest secret for decades. In March 2022, he broke his silence, releasing the paper explaining why it works, but not how it worked, stating the following: "A month ago, releasing this paper was unthinkable. So was a Russian war with Ukraine. Now that there is this clear and present danger, it's time." Hings had developed an instrument which picked up all manner of aircraft in flight around Vancouver, Canada, and it wasn't done with radar. It detected the propagation of atmospheric ions. Anything that moves through the air causes wakes of ions to propagate ahead of the aircraft much faster than supersonic or even hypersonic speeds. The instrument could detect and track a commercial airliner for over an hour in flight, which is well over the horizon, and functioned passively with no outgoing signal, whereas radar and LiDAR are active and must send out a signal and are limited to line of sight. There are a few exceptions with over-the-horizon radar, but these are very large systems like HARP and HIPAS in Alaska. The Hings and Kramer team also detected and tracked military and civilian helicopters and small private planes for over 6 years. Kramer says that they became quite good at being able to tell the difference between different makes and models of aircraft just from their signatures, without any computer analysis. The team was also able to track the entire 2-hour flight of the supersonic Concorde jet when it flew out of Vancouver, over the Pacific Ocean, where it went supersonic for over an hour, and then returned and landed back at Vancouver Airport. It was marketed at the time as the flight to nowhere. Kramer explains the significance of the landing track of the space shuttle. There are a few things we can take away from this re-entry and landing of the Space Shuttle Discovery detection event. There was no apparent lag between any of the maneuvers and detection time. The shuttle has to make those 4 S-turns at precise times. Prior to landing, the space shuttle is a hypersonic glide aircraft entering the atmosphere at Mach 25. This means that hypersonic weapons and aircraft above Mach 5, which is around 3,853 miles per hour, can be detected and tracked, even if they are gliding unpowered and regardless of their maneuverability in real time. Cruise missiles that fly low to avoid radar detection could also be tracked and thereby intercepted, as height has no bearing on detectability. This also applies to Special Forces aircraft and helicopters that use stealth or fly low to avoid detection. This was mission STS-31 when the Space Shuttle Discovery carried the Hubble Space Telescope and placed it into orbit. Kramer continues, "The ions themselves don't travel at these high speeds from the shuttle to our instrument sensor, but they cause a wave front that propagates away from the craft at what we estimated to be at about 1/3 the speed of light, which is, for argument's sake, immediate. If we look at tidal waves or tsunamis as an analogy, the water particles don't move at 500 miles per hour. They can't, but the wave itself does." The Canadian government has ruled that it is non-classified, and Guy is not limited with who he can deal with other than countries that no Canadian company is allowed to deal with. Guy had set a 2-year time limit for the U.S. government or U.S. defense companies to acquire it, which just passed. The Five Eyes countries, Australia, Canada, New Zealand, the United Kingdom, and the United States, were going to be the next to be able to potentially acquire. However, as 2 of the 5, Canada and the U.S. seem uninterested. Guy is going to skip the Five Eyes time limit and open it up to NATO countries, many of which have begun to rethink their own internal defensive capabilities amid the previous 2 years of variable support from some NATO countries to Ukraine. Guy Kramer explained how they could enhance the instrument. While our directional instruments could only provide a bearing on the object, 2 directional instruments far enough away from each other would be able to triangulate to the precise location of the object being tracked. U.S. stealth aircraft such as the F-22, F-35, F-117, B-2 bomber and the new B-21 bomber and undisclosed 5th and 6th generation aircraft are just as vulnerable to this detection and tracking. Previous research conducted by Hings in the 1960s demonstrated his early instrumentation had the ability to track ships and submarines. In this case, the submarine USS Cayman with the designation SS-323 was sent up to Vancouver for that testing, which Hings successfully tracked. Hings learned in the 1980s that a U.S. defense company tried, without his knowledge, to duplicate his results but were unable to do so. In 2013, Guy was asked by the U.S. Naval Research Lab in Washington, D.C. to speak to their counterparts in Canada about this technology. Guy met with a team in Ottawa at the Defense Research and Development Canada, or DRDC for short, and they began a 1-year study to attempt to duplicate Hings' results, declining Guy's offer to help them, stating in their follow-up report that Guy doesn't understand science. They too were unable to duplicate the Hings-Kramer results, and Guy believes he knows why. The DRDC then told Guy that the technology would not be classified, and he was free to do with it what he wanted. The U.S. Navy Research Lab then declined further cooperation with Guy, likely due to the inability of the DRDC to track aircraft and their final report, which dismissed Guy's knowledge base. 11 years later, in 2025, Guy Kramer now holds 16 patents in the field of optics, with over 500 patent claims granted with a light-bending material, which has demonstrated the ability to make a target invisible, a solar panel amplifier, which can triple solar panel output, a laser splitter, which can split a laser into over 10 million lasers, and a holographic, video display system. It now seems that the DRDC vastly underestimated Guy's comprehension and may have passed up on one of the most important scientific discoveries of our time because they refused Kramer's years of experience due to his lack of a formal college or university education. Guy points out that his grandfather went through a similar process, as he also lacked any post-secondary schooling. Hings too was dismissed by scientists and engineers and had to prove himself through his discoveries and patents to gain any credibility. It appears that even 21 years after his death, Hings is still confounding his peers. Kramer concludes, "This is not a hyperstealth product. However, if a defense company or government agency wants to work with me on my grandfather's aircraft detection technology, they will first have to acquire my hyperstealth patents. I have 150 investors that are my primary concern right now. I will not walk away from them or get sidetracked by this other technology until they are first taken care of."